Hello, and welcome to this presentation, Understanding Channel Power. In this short presentation, we'll explain what channel power is and the three most common ways that channel power is measured. If you're unfamiliar with spectrum analyzers in general, it would be a good idea to watch the presentation, Understanding Basic Spectrum Analyzer Operation, before continuing with this presentation. In order to understand channel power, we first need to define what we mean by a channel. When signals are transmitted by wireless communications and broadcast systems, they're often assigned specific frequency ranges or channels. Normally, most of the signal power should stay within this channel. A channel can be defined by a start and stop frequency, but more commonly, we define a channel in terms of its width and center frequency. Channel power is defined as the sum of all the power in a given channel. That is, it's a measure of the total power within the defined channel bandwidth. We can measure channel power in different ways, and in this presentation we'll cover the three most common methods. Channel power is an absolute power measurement, with results expressed in units like dBm. Note that in some cases, a signal's power may extend or leak beyond the edges of a channel. The measurement of this leakage, or energy outside of the channel, is called ACLR, or Adjacent Channel Leakage Ratio. ACLR will be covered in a separate presentation. Channel power is a very common measurement, especially for signals that are used in wireless communication services. There are three main ways in which we can measure channel power. The first is using an RF power sensor. We can also use a spectrum analyzer to measure channel power, either using the zero-span method or the integrated bandwidth method. Let's start with how a power sensor can be used to measure channel power. An ordinary RF power sensor can be used to measure channel power, and this method has several advantages. It's a very simple measurement, power sensors are relatively inexpensive, and they're also portable, which is important because this measurement is often made in the field. Depending on your power sensor, it also yields very accurate results. No special configuration is needed to measure channel power with a power sensor. We just connect the sensor to the signal and read the results. The power sensor method only works if the signal we're measuring is the only signal present at the sensor's RF input. If other signals are within the power sensor's bandwidth, these have to be removed before we measure channel power. Otherwise, we'll be measuring the sum of all the power in the sensor's bandwidth and not just the power of the channel that we're interested in. Another way we can measure channel power is using the so-called zero-span mode of a spectrum analyzer. In this case, instead of sweeping across a span or range of frequencies, the analyzer is basically parked on the center frequency of the channel with span set to 0. The analyzer measures the power within the resolution bandwidth, and channel power appears as a line on the display. Power can be read off manually or using a marker. Remember that in zero span, we need to use the RMS detector because we're measuring power. When making channel power measurements in zero span mode, a resolution bandwidth slightly wider than the channel bandwidth should be chosen. For example, if we have a 1.4 MHz wide channel, a 3 MHz wide resolution bandwidth would be appropriate. This can be problematic when trying to measure wider channels, like those used in wireless communications, because a spectrum analyzer may not have a resolution bandwidth that's wide enough to cover the entire signal. Also, just as in the case of power sensors, there should not be any other signals present within the resolution bandwidth. One final note. Generally speaking, increasing the sweep time in zero-span mode tends to yield better measurement results. Now let's describe the last of the three main channel power measurement methods. Most modern spectrum analyzers can automatically calculate channel power given the channel bandwidth and frequency. This measurement is done by integrating over the channel bandwidth. So this method is sometimes called the integrated bandwidth method. And just like the zero-span method, this method also requires the use of the RMS detector. So in summary, channel power is the power contained within a channel, that is, power over a given bandwidth or between two limits. There are three main methods for measuring channel power: using an RF power sensor, using a spectrum analyzer in zero-span mode, or using the so-called integrated bandwidth method, in which a spectrum analyzer uses a narrow resolution bandwidth to integrate the power within a channel. Since channel power is a power measurement, our detector type should always be set to RMS when we measure channel power with a spectrum analyzer. This concludes our presentation, Understanding Channel Power. Thanks for watching.